Hello, everybody. Do you all have your headsets, or do you all speak English fluently? So welcome. I'm very happy to be here. This is my first time stay in this lifetime in Russia and in St. Petersburg. And I was very excited to come here. And thank you, RIPE, for inviting me to speak to you. And so the first thing I want to do is just pick up on the question I heard before on IP version 8. I can tell you what the next version of IP is going to be. It's Vint Cerf. Do you know Vint Cerf? He's known to be the father of the internet. He was one of those few visionary guys developing IPv4 in the early 70s when nobody had a concept of the internet. So do you know what he's working on these days? He's working on the interplanetary communication protocol. And this is about how are your grandchildren going to send SMS text messages from Mars down to planet Earth when they are on the side of Mars that is not facing the Earth. You know, a TCP window size will not do the job. So that's going to be IP version 8. So just shortly before I start with my presentation on my person, my name is Silvia Hagen. I have a consulting company in Switzerland. I am the author of IPv6 Essentials, which is the O'Reilly book. Unfortunately, there is only an English version of this book. Maybe O'Reilly will translate it to Russian at some point. We don't know. And I do consulting for IPv6 since many years, and I teach classes, so I have many years of experience working with IPv6. And I want to speak to you on how to save money with IPv6. And you may be surprised about this because most people think that IPv6 is only going to cost a lot of money, but not have a business case. Now, I try to show you a different perspective to this. So the first thing I want to introduce 3 terms which will show up again and again through this presentation. I am redefining UTC. Normally UTC is Universal Time Coordinated, right? In my presentation it's not. It stands for Users, Transit, Content. And these are the 3 elements that we need if we want to have an active IPv6 internet. Only if those 3 components work on IPv6, we have an IPv6 internet. Or if they work on IPv4, then we have an IPv4 internet. So we need users that are capable of accessing the internet over IPv6. We need content, being websites that provide their content over IPv6. And between the 2, obviously, we need a highway, a road, a transit system that supports the protocol, so that the IPv6 users can reach the IPv6 content. And this is known as the YouTube effect. Now I know you here in Russia probably have other websites than we do in Europe, but you may know that what YouTube is. It's owned by Google. So in December of 2009, Google added a Quad A record to the DNS for YouTube. It was already dual stacked before, but as long as it does not have a Quad A record in DNS, it can't be found by the users. So the moment that Google added the Quad A record to DNS, this red line is the IPv6 traffic that came into the site. And it's known as the YouTube effect. It shows that there were many IPv6 capable users out there, but only the moment that the content provider announced his service in the DNS to be reachable over IPv6, all these users could come with IPv6. Before, they just came with IPv4. So in this presentation, we are going to talk about these 3 elements. By the way, one thing that I have to say, these users here, they were dual stack, right? So they have both protocols. So in the internet, it's important that in the future, users as well as content providers are dual stack. And if they are, IPv6 is always the preferred protocol. That's why this shift happens the moment you implement the name, the service name in DNS. So let's look at the growth of the internet first. This is a website where you can just get general statistics on the growth of the internet. So this graph is not IPv6 related, it's internet users. It shows the population of a region. Here, this is the population in the world, global, and then it's broken down on the regions like USA, Canada, Europe, Middle East, etc. And it shows the penetration rate, which is how many people of the total population do have internet access. So currently, if we look at it from a global perspective, approximately 35% of the people on the planet have internet access. And then you can see big difference, like USA and Canada, they have a penetration rate of 78%, where, for instance, Africa has a penetration rate of 15%. So the regions where we have a low penetration rate are the regions where growth is going to be fastest. And now we have to understand that regions that grow fast now, because they're currently low, they will most probably grow over IPv6. Because why should you deploy IPv4 on a large scale in a region where you have no internet access if that's an end-of-life technology? So the growth regions are going to be strong in IPv6, maybe even earlier than the well-developed regions. And here you see how fast the internet grew. The world had an online user base of 360 million in 2001. So that's just one first indicator of how fast the internet is growing. And this is important for us to understand if we project into the future, how fast is it going to grow? Are you all doing fine and understanding what I'm saying? Who of you has deployed IPv6? Oh, quite a few hands. That's nice. Are you all ISPs? Are you ISPs, the ones that, yeah? Not too many? Good. So when I come back in a year, Russia's going to be the leading region in the world? Deal? Okay. Well, I certainly love to come back. So we look at transit now. The slide before was internet users in total, protocol independent. Now we look at transit. We need transit. How do we do with transit? These are the top transit AS, autonomous systems in the world. This is a statistics that you can find on sixlab.cisco.com, or maybe you have a Russian list that shows you the same. It shows that from the top 20 transit AS systems, so that's like the top 10, 20 systems that carry most of the internet traffic on the planet, 100% are IPv6 enabled. That's good. Even if we go down to the top 300 global transit AS systems, more than 75% are IPv6 enabled. So we can say the IPv6 internet highway is in place. Okay, we have transit. That's not a concern anymore. And now we look at content. That's the statistics from the World IPv6 Launch website. It does not look too happy because we're on way like below 50%. It's the top Alexa 1000 websites. So this is now content from a global perspective, the top 1000 Alexa websites in the world, and we see that 13% have IPv6. So this is actually, from a global perspective, where growth must happen now. We need to encourage those big websites to go IPv6. We all need it. It helps everybody. But still, we can say 14% is not too bad. And for instance, I did a survey. The Swiss IPv6 Council did a survey with the top 75 Alexa websites in Switzerland. And some really big websites, they have plans to enable to dual stack their website by the end of 2014. So I spoke with many content providers, and they all are on the roadmap for end of 2014 or early 2015. So we expect a lot of content to come up. I have this picture for Switzerland. I assume it will be similar for European websites and also for American websites. And a slide a little later will show that you in Russia are doing pretty good when it comes to content. Well, it's not working anymore. Oops. What's happening? Okay. What? Huh? It's not moving. Yeah. Is the battery empty? Can you try mine? I don't know where I put mine. It's in my bag. Doesn't work? It's in my bag. I'm sorry. Can you tell me a little Russian joke? A short one? No? This one? They fixed it. So, this is the depletion of the IPv4 pool at IANA, right? IANA is the worldwide organization that gives out space to registries like RIPE and ARIN and APNIC. And this is how we measure the depletion of IPv4. And while this measures the depletion of IPv4, it's also an indicator of how fast the internet is growing, because that's how we consumed IPv4 addresses. And so, as Maxim has explained, we count IPv4 address space in /8, which is a block A, an address block class A. And if we followed this development over the last 15 years, we had an average consumption rate of 10/8s per year. That was just average. It was a little more in one year, a little less in another year, the average. We entered January 2010 with 24/8 blocks still left in the global IANA pool. So it should have been sufficient for at least 2 more years, right? If we consume 10/8s a year, 24/8s are good for at least 2 years. 1 year later, in February 2011, IANA announced the depletion of the pool. Boom! In 1 year, more than 2 times faster. Consumption rate more than doubled. What happened? They were all Asian broadband providers acquiring that space. Somebody in Asia burned 1/8 in 3 weeks in December of 2010. So this can happen again, right? This is only important to us to understand how fast the internet is growing, because now we're out of IPv4. So how will the internet grow in IPv4? Oh. Okay, I have to go back. I thought I can jump to another slide. Let's take it one by one. This, again, this is the map from Google Statistics. Here is the link. It's just a very short overview. I will give Maxim the slides as a PDF, and he can give them to you, so you can all look this up later if you want. This is user adoption rates. So it says the United States has an IPv6 adoption rate from a user perspective of 7%. means 7% of the people that have internet access in the United States are dual stacked. It shows Belgium is the leader right now with 16%. They are the leader because most Belgian ISPs have dual stacked their users and enabled it by default. So many Belgian internet users, they have IPv6, but most of them don't even know. And they don't care, and they should not have to care. That's perfect, that's how it's supposed to work. France is on 5%, Germany on 8%, Romania on 7%, Switzerland on 9%, and Japan on 3%. If you go to the statistics, you can look up the numbers for every country you're interested in. But on the Cisco page, you find a little more information, and I want to look at this. I was obviously looking up Russia because I'm coming here, so I was curious to understand how you're doing here. It shows different numbers. The first percentage here, it's called IPv6 deployment. The website has a detailed information that shows exactly how these percentages are calculated. So I'm just giving you a general overview. So this is a measurement which includes everything, users, transit, and content. It looks at transit AS system. So in Russia, 43% of the transit AS systems are IPv6 enabled. And this number is not linear. It's like you have approximately 800 transit AS systems in Russia, out of which 100 are IPv6 enabled. But it's a lot more than 1/8 because it's weighted. So the transit AS systems that carry a lot of traffic, much more than others, they get a higher weight. So that's how the site tells you that 43% of the transit AS systems that are important here support IPv6. And also on content, Russia is doing pretty good. Like the users that have dual stack internet access, they have 34% of content available over IPv6. What does that mean for a Russian ISP? If you deploy dual stack IPv6 to your internet access user, you can expect that they will approximately have 34% of their traffic going over IPv6, right? And then we have users, and here you are pretty low with 0.25%, but don't worry, Italy and the UK are also below 1%. So you're in good company, but I would say that with the transit and the content being so high, it would really be a good time in Russia to work on deploying internet access to users because there is content that they can reach over IPv6. And this is where you can save money, and this is what I'm going to show in a later slide. So to compare, Germany, they have 81% transit AS systems. On content, they're on 48%, and on users on 8%. Switzerland, we are on 79% transit, 52% content, and I know that this will substantially go up by the end of 2014, and we are on 11% users. So you can go to this website and look it up for any country. So how many users are there? So these are the numbers from this slide. It shows in Switzerland we have 9% of IPv6 users, which is because we are a small, nice little country, only 650,000 users, right? Where the US, they are on 6%, and that's 15 million users. So it makes a little different. But to be seen globally, we have 7 billion people on the planet, 2.4 billion, 34%, have IPv6 internet access, and that equals approximately 84 million people, excuse me. And this number was only 12 months ago. So in May 2013, we were on 1.4%. That's how fast the IPv6 internet grows. It's factor 2.5. And if it continues to grow like that, with factor 2.5, there will be more than 50% IPv6 users in 2017. So, is it time to move? Yes, it definitely is. Maxime has been speaking about this. The 3 main registries, APNIC for Asia Pacific, RIPE NCC for Europe, and ARIN for the United States, all the 3 are allocating from the last /8 which comes down to the very restricted allocation rules of only a /22, which is approximately 1,000 addresses, correct? So you cannot really start a business or grow your business if you only get a /22. So providers have to become creative if they want to grow their business. So the internet grows. Total now, this is not IPv6 perspective, this is just internet. 2001, 360 million, 2009, 1.4 billion, 2012, 2.3 billion, and that was the end of IPv4. So that means that the growth from now on will happen over IPv6, mostly. And so you can see the consumption rate doubled in 2010. We don't know if things like that are going to happen again. If we sort of take it linearly, we can expect the internet to be 5 billion or more by 2017, but with a much higher IPv6 percentage. So, summary, investing in IPv4 is an investment in an end-of-life technology, and investing in IPv6 is an investment in the future technology. Now, we're still waiting to get to the part where you can save money, right? But we're getting there, promise. So what does that mean? All we have seen so far, it means the internet can only grow really substantially over IPv6. Providers will have to use two ways in order to provide IPv4 access to the IPv4 internet. So we have two internets now. We have an IPv4 internet, and in parallel, we have an IPv6 internet, right? So a provider cannot get new customers and tell them, oh, I'm only giving you access to the IPv6 internet. You know, I ran out of IPv4 addresses. People will say, hey, wait a minute. Most of the content is IPv4, so you have to give me IPv4 access. Now, what does the provider do if he doesn't have IPv4 addresses? He can do either NAT, and in many cases in the future, he will need multiple NATs, like CGN, carrier-grade NAT, to extend his IPv4 address space. Or he can deploy IPv6 only to his customers and use a translation mechanism to access the IPv4 internet. That's his two choices. He cannot, if he doesn't have public IPv4 address space, provide native IPv4 internet access. So that means that new internet users in the future, they will have a translated or NATed IPv4 internet access, and hopefully more and more native IPv6 access to the IPv6 internet. That's the typical internet user of the future. So that means internet access to IPv6 websites will soon outperform access to IPv4 websites. It even does so today. I have a friend who deploys a tool that measures internet access globally from different access points and compares it. And even today, IPv6 access to dual-stack websites is usually faster than IPv4 access. Now, the problem for content providers is that if they only provide their website over IPv4, even dual-stack users have to use their NATed or translated IPv4 internet access to come to that website. Which means if the website is a little more complex, has maybe authentication or is an e-commerce shop, it may have problems, performance issues, or fail. And your only protection mechanism as a content provider is to offer your website dual stack, because chances are that users can then come with IPv6 natively. So this is why IPv6 internet access will soon outperform IPv4. And also you have a problem with all these NATed and translated mechanisms. Analytics don't really work, geolocation doesn't really work, so you have multiple problems in consequence. So, the IPv4 internet has reached its end, its error code 405, end of internet reached. Get outside in the fresh air, read the books you never had time for, do whatever. If you want to grow the internet, if you want to be part of the future internet, you have to use IPv6. So, are you familiar with CGN? Yes? The point here is that usually subscribers used to have NAT here, which means they had private addresses in their home or small office, and then they had a public address outside here. That was traditional NAT. Now with CGN, there is a second level of NAT, or even more than one second level of NAT, by assigning a private address again here and have only one public IPv4 address to the internet. Which means now multiple customers are sharing one public IPv4 address. And that's a killer for different reasons. I mean, NAT, we know the problems with certain applications. We have learned to work around them. Now we have 2 levels, so the problems may increase in numbers. More applications may fail, but we have other issues. As I said, a customer cannot be identified by his IP address anymore because multiple customers are now sharing this one public IPv4 address. So if one of these customers is a bad guy, the address goes into a blacklist. Oops, too bad. Everybody gets blacklisted, right? If somebody attacks this public IPv4 address, all customers are affected, and not just one. So you can see there are several issues in the background. So basically, the message is there will not be a way around CGN in many cases, just due to that there aren't any more addresses available, but we have to avoid it or limit it as much as we can because there's too much negative consequence from using it. Another issue with CGN is that all these sessions that these customers build to the internet, they are limited because they need ports. Now, one gateway just has a limited number of ports available. And if all those customers use many sessions, they run out of ports. And when they run out of ports, applications fail because they cannot build any more connections that they would need for proper functioning. So that's your bottleneck, the CGN. Costly to implement, costly and difficult to manage. We have a log issue. I don't know about Russia, but in Switzerland, providers have to keep all data for 6 months. Same here. How long? 3 years? Oh gosh. Now, imagine how you have to change your log files, because now you have to be able to provide the information per customer. So you have to start logging your ports. So I know that the Swiss providers, they're freaking out about this. Then we have the security blacklist problems. We have failing applications. This is a Google Maps. You see all those empty spaces? This is what Google Maps look like if you can't get any more connections because your CGN is out of ports. Not a very good thing. I can maybe live with it when it's Google Maps, but some more critical business applications, I may have a bigger issue if that doesn't work. Geolocation doesn't work. The only way out is deploy IPv6. This is just to show the fact with the port limitations is that our applications, they need more and more sessions, connections, meaning more ports on a CGN. This is an analysis Alain Fiocco did at his home network. He has 2 kids and a wife, so there were 4 people connected to this network, and he took a tool and tracked how many sessions each application used. And so you could say that even an average home with 4 people doing some regular surfing in the evening needs at least 500 ports. So you can estimate, I think a gateway has some 65,000 ports, and you can work out how many customers can he connect to make sure nobody runs out of ports. Also, this shows how our applications get more and more hungry for ports. This is an 8 months overview of the port connections of a mobile network, and they did not implement any new service. That's just stable over 8 months how the ports increased. So then, that was the CGN part. Now we get to the translation part. Who knows NAT64? Okay, not too many. So just very short. If I don't want to do CGN, I can say I deploy IPv6 only to my client. But he still wants access to the IPv4 internet, correct? So we have a NAT64 gateway here, and this mechanism works with a DNS64. So because he only knows IPv6, you enter a service name, which is IPv6 capable, meaning dual stack, like YouTube. Then the DNS will just return an IPv6 address. And this guy will make a native IPv6 connection. Easy. Now, this IPv6 only client enters a service name in his browsers that is not available over IPv6. So, because he's IPv6 only, he will always ask for a quad A record, right? Because that's the IPv6 address record. And there is no entry in DNS because that service is not available over IPv6. But this is a DNS64 server, so he's pretty clever. He knows what this guy is trying to do. He says, well, let me check if there is an A record for this service type. So the DNS server goes out and tries to find an A record for that service type. And he will find one eventually. He's going to reply to this client with a synthetic quad A record, which has a special prefix and carries the IPv4 address in the last 32 bits of the address. So this guy is going to initiate a TCP handshake with this address, and that's how the packet is going to go through the NAT64, which is going to translate the IPv4 packet. Pretty clever. So that's what many can do in the future. This supports the deployment of IPv6 only networks. So in some cases, it's maybe a leaner mechanism than CGN is. Because it lets you deploy IPv6 only to your end devices, which means you have to maintain only one protocol, but still give them access to the IPv4 internet. And there are some applications which have literals, which means, like for instance, Skype. You know Skype? So Skype would not work in this scenario because it fails at the translator. But there is a new mechanism, which is called 464 XLot, which even makes Skype work. So with 464 XLot, it's sort of a combination between stateless and stateful NAT64. And it allows every application, IPv4 application, to work on an IPv6 only device. And it has been deployed large scale in the United States by Verizon Wireless and T-Mobile USA, millions of customers that have IPv6 only devices, and they are happy. So we think that is the trend. It's tested and implemented on Android, and others are working on it. So he told me I have 5 minutes. I will have to hurry up. So that's XLot. You can have this slide and you can find out for yourself. So XLot makes IPv4 applications work on IPv6 only. Very cool. But only as an emergency. So the strategy for a provider should be to have CGN or NAT64, but only for legacy. And in parallel, you must, for your own sake and business case, deploy native IPv6 because this offloads all traffic from here, right? Because there is the default rule that for all dual stack cases, IPv6 is always preferred. This means that everybody that goes IPv6 will not go through this gateway, which reduces your cost substantially to maintain and scale this gateway here. And as you have seen, with Russia being on 34% of content already, probably with a fast-growing trend, this will be a really helpful mechanism because here, 34% of the traffic will already use this IPv6 native pathway. So this is an example. This is my little house up on 1,500 meters above sea level in the mountains. People have cows there. They don't worry about IT. And I have dual stack internet access. My neighbor is a teacher there, and he has a Mac, and he asked me to help him install his email application on his new MacBook. He doesn't care about IP version, and I checked. and he has IPv6. He doesn't know, and he doesn't care, but it works. So that's how it's supposed to be. So IPv4 is the preferred protocol. This is a DNS query. If you ask for DNS services on a dual stack client, you will always see a query for an A record and a query for a quad A record. And then DNS returns 2 addresses if it's a dual stack service. And if the client has a choice, because he got 2 addresses, he will use IPv6 in most cases. So this is the business case. It's a study by Cisco. You can download the whole PDF if you're interested in the details of how they did it. It's a service provider with 5 million subscribers, each home allocated 500 sessions, annual subscription growth rate 10%, and they assumed that in the internet there was 25% in the first year available content, growing up to 95% within the 5 years of the comparison. So this calculation shows how the provider does cost-wise if he only goes for a CGN NAT strategy. This is how much it's going to cost him in the 5 years to maintain, scale, manage, deploy his NAT with a growing customer base, right? So he has to extend it and extend it. And this is the same environment, but this provider does IPv6 in parallel. So that means, yes, in the first year you will have cost. You have to deploy IPv6, but once it's out there, it's almost zero maintenance. It's easy, it's native, it doesn't have a problem, and it takes off traffic from this costly version here. So that's why over a period of 5 years, if you do both, you will save 30 to 40% of your annual IT costs on the maintenance of this. So definitely something to look at. Similar stuff. So my summary before they cut me off. Content providers want to be reachable over both protocols to provide an IPv6 path for internet users with bad IPv4 connectivity. Got that? So keep working on your content providers. Ask them if they don't have enabled IPv6. Then, next, internet access providers want to provide native IPv6 in parallel to IPv4 in order to offload traffic from NATs and CGNs. And they do that for themselves because it reduces their costs and their pains and their sleepless nights. The faster we all deploy native IPv6, the easier it becomes for all of us. And from my consulting, I can say that in enterprise networks, so now we're not talking about public internet, but the network inside a company, the trend is to go native IPv6 only as soon as possible. Doesn't mean tomorrow, it's maybe in 3 years, but as a strategy. And so one clear example of this is Facebook. You can imagine, you know Facebook, right? You may not use it, but you know it. So they have high-level data centers with lots of devices, virtualized machines, whatever, crazy stuff. They are removing IPv4 from the data center now. They're not planning it, they're doing it. They say we have 100% of the hosts in our network are dual stack, and 75% of our internal network traffic today is IPv6. So that's where it's going. They are leading ahead. Many will follow this path. The strategy is IPv6 only as soon as possible. Treat IPv4 as a service and only support it where needed. So access providers in Russia deploying IPv6 today can expect approximately 35% of the user traffic to be IPv6 today, trend growing. Top content providers should move their website to dual stack. This will increase the share on IPv6 traffic and help providers to minimize cost and CGN NAT translation. So encourage hosting providers to go IPv6. And I read in the news, a friend sent the link to me that there are some larger LTE deployments coming up in Russia in the next 5 to 7 years. And who are these guys here? I'm not asking. But anyway, if you roll out a new service, it's the time to go IPv6, right? Why should you develop and test and deploy on IPv4 if it's an end-of-life technology? if you have these big investments coming up to deploy a service in such a large scale, to connect so many new users, do it IPv6. This is your big chance. And it's going to help everybody. So that's why I said, when I come back, maybe in 3 years, Russia is going to be the leading region, right? So this is how you can reach me if you want, but you have to write in English. I may find a friend, though, who could translate Russian to me. This is my new book coming out. It went to the printer yesterday, so it's going to be available in about 2 or 3 weeks. And so I hope that I managed to give you my viewpoint on where things are going. I would like to take questions. I don't know if we have time. We do. So if does anybody have a question? She will translate it for me. You can ask in Russian. Yes?
My name is Dmitry. I wanted to ask for the books. Do the authors select animals, and why is the snail there?
Thank you. So it's worldwide, it's known as the Snail Book. And as an O'Reilly, you know O'Reilly is like the big IT book publisher. When you sign a contract as an author for O'Reilly, the first paragraph says the author does not have anything to say about the choice of the animal. So I did the first edition back in the year 2001. There were about 5 people on the planet that knew what IPv6 was, and they were the developers. And they were really happy that O'Reilly did a book on their protocol. And so they carried me on their hands and helped me with the book. And when they saw that O'Reilly had assigned a snail, they screamed. And so did I. So I wrote an email to O'Reilly, and I said, I know you don't care about my opinion, but I have to say something. And so, as you can see, it's very obvious they kept a snail. So I said to the developers, you know, this is an IPv4 snail. And she sits there and she thinks like, how can something be so fast like IPv6? And so the developer said, yes, we can live with that. Thank you for the question. Any other question? Yes, one question back there.
2 years ago, during the world launch of IPv6, there was a discussion here about the terms when IPv6 will fully replace IPv4. So there were a lot of opinions expressed, very grounded, and the timeline was from 5 years until the end. Some people spoke about 20 years. Do you have any forecast in this relation?
Well, I do not have a crystal ball. I have an opinion. As my IANA depletion pool graph showed, we had 10/8 degradation of IPv4 addresses for 10 years. And then suddenly, in 1 year, it more than doubled. Nobody can anticipate that. The only thing I think we can say with clarity is that the internet and new services will always grow faster than we expect, because they don't grow linearly, they grow exponentially. So my assumption is, if you saw that slide where I say a year ago we had 1.4% global user adoption, 12 months later we have 3.5% user adoption, it's 2.5 times more. If you extrapolate that, 3.5 times 2.45 in 1 year, again and again, in 3 years, it's more than 50%. We will have IPv4 around in 20 years, but it's going to be small. It's not going to go away. So for public services, I think we should plan for dual stack for a long time. But I do believe that within the next 2 to 3 years, IPv6 will already be the dominant protocol in the internet.
Спасибо.
Thank you. Thank you very much.
If it's okay with you.
I don't hear anything. Oh, sorry, I didn't get.
I'm an ISP, and I have 2 questions to you, if it's okay with you. Okay. The first question is, from my point of view as ISP, it's easier for me to deploy IPv6. And
It's
from
easier?
Yeah.
You say it's
and
easier.
from my point of view, the showstopper is content. Content is the main thing that stops us to implement IPv6. Because customer says, why we need this IPv something thing? It doesn't do anything for us. What do you think? What is the main showstopper in implementing IPv6, content or users?
So the question is, what is the main showstopper? And we
Yes.
cannot answer that question in such a general way. When you say my customer doesn't care, who is your customer?
General people,
Like residential users?
like residential users, yes.
They don't care. Like the teacher?
They don't care, and we...
Like the teacher with the cows? He doesn't care.
They doesn't care, as you told. And we implement IPv6.
Right,
yes.
the provider has to
Yes.
make a choice?
As provider, we implement IPv6, that's okay.
Yes.
But we see that there are no growth of content, IPv6 content. We have some, what did you say, 34% in Russia.
Which is big
Which is, yes, it's
for
big.
the time.
Yes. But it's not growing for a long time.
Are you sure? Why are you saying
Yes.
that?
It's not growing anymore. There was some time that there was growing rapidly with Google, with some Russian providers.
Yeah, I
content
heard you have
providers.
some big Russian
Yes,
websites,
yes.
right?
But then it stopped. It basically stopped. And we as ISPs can do nothing to help content providers
Okay.
implement IPv6.
So if I was a large content provider in Russia, so the first answer is there was some initial deployment on content. That's how you got to 34%. And there will be more. Maybe there is a slight stop right now. There will be more coming. But if I was a major content provider and I see like 0.25% users, why should I deploy? So I think the next people that have to move here are the one that provide access to users, because the content provider only have a case if there are also users that can come to their website with IPv6. So I don't think that, things are not moving on here. I think that it will move on. I think you have a good base to start from. And as soon as users are going to go up, content providers are going to jump on the bandwagon again. Does that make sense?
Oh, yes. Thank you.
So I really think Russia needs users now. And I'm working in Italy, I'm working in the UK because they are on 0.2% also. And that needs to change. And I know so many providers, including the people at Swisscom in Switzerland, who basically did the 10% that we have in Switzerland. And I just know that it's not a killer. So I just encourage you and everybody you know that provides internet access to work with internet access providers to increase that number of users. And that will make the content providers follow.
So your answer is, the main question is users.
Yeah,
Give
right
us
now.
users and
Yeah.
we get it.
Get to 5–10% with the users.
Thank you.
That were your 2 questions?
Oh, we covered
Okay.
both. Thank you.
Thank you. Any other? No? No more questions? Well, I'm going to be hanging around, so if you can speak English or have a friend that does, you can always ask me questions offline. I thank you very much. It was a pleasure to be here. And most of all, enjoy life. That's what we're here for.